Okay, everybody, this calculus lesson is on velocity application problems. Let's go ahead and begin. Rate equals distance divided by time. Remember, distance equals rate times time, so rate is distance divided by time. And there's two types of rate and velocity kind of problems. One is the average velocity, and the average velocity occurs over an interval over two coordinates, you guys, so two times. So you do S of t minus S of t2 minus S of t1 over t2 minus t1. S is the position and t is your time right there. And you're, instead of having like f of x equals the equation, you're going to have S of t equaling an equation. All right, and then instantaneous velocity occurs at a specific time. So instantaneous velocity means you're going to take the derivative and you plug in that specific time. Okay, so average velocity, use this formula. Instantaneous velocity, we use the derivative. Okay, and so just note that the average velocity has a start and end time, and then the instantaneous velocity is when it's asking specifically a time. Speed's always positive. Velocity is speed, but it's positive when you're going up or to the right, and you'll get a negative number when it's going down or to the left. So you'll see in just a second. So for a ball that's dropped 100 feet, its height s at time t is given by this formula. S of t equals negative 16t squared plus 100. Find the average velocity over the interval, so I'm going to use that average velocity formula for that. Do s of 2 minus s of 1 over 2 minus 1, and then find the instantaneous velocity. So that's where I find plug the derivative in. So the derivative is negative 32t. Plug in 1.4 into that. Okay, let's go ahead and do the first one there. Okay, so I do s of 2 minus s of 1. I did that up here. So it's 36 minus 84 over 2 minus 1 gets me negative 48. Don't just write negative 48. Put it in terms of the context of the problem there, you guys. So negative 48 feet per second, okay? Because it's talking about feet, and it's talking about seconds, so negative 48 feet per second. Okay, and it's negative because it's going down. Okay, and then since it's for instantaneous velocity, we're going to go ahead and get the derivative. So the derivative is negative 32t, and then just plug in 1.4. Okay, and then these answers should be close to each other, you guys. They should closely match. I know if you take the AP test, you high school kids. Um, uh, they like you to be recognized that they're going to be close to each other right there. Okay. All right. So at time t equals 0, this is another problem. A driver jumps from a platform 32 feet above the water. Her position is given by negative 16t squared plus 16t plus 32. What's the diver's hit? When does the diver hit water, and what's the diver's velocity at impact? Okay. So look at that groovy picture I drew, and isn't here's our hero right there, and she's going to dive, and so when she hits the water, she's going to dive, and her height is going to be 0. Okay, so when she hits the water, I'm going to set this equation equal to 0 and solve for t. How long is it going to take her to hit the water? All right, and then if your book, most books put S of 0 just means your initial position, and V sub 0 equals your initial velocity. So my initial position right here would be S sub 0, and my initial velocity is uh, uh, V sub 0. Sorry, you guys, a little brain freeze there. So when she hits water, you set that equal to 0. I can pull a negative 16 out and solve that equation, and I get t equal 2 seconds or t equal negative 1 second. I know it's not negative 1 second, so she's going to hit the water at 2 seconds. Okay, so what's the diver's velocity at impact? Okay, so the diver's velocity means derivative. I'm going to take the derivative, and then I'm going to plug in t equals 2 seconds at impact right there. So here we go. I'm going to plug in t equal 2. So her impact, her velocity at impact is going to be negative 48 feet per second. Okay, that's it. And if you're in my class, I would assign that as your homework right there. Take care.